Welcome everyone to STEM Talk session 12 of the 7th Polygence Symposium of Rising Scholars. My name is Jin. I'm one of the founders of Polygence and I will be moderating today's session. Super excited to hear all of your presentations. The goal of this symposium is to celebrate and showcase the hard work that all of you Polygence scholars have done, and you guys have all worked tirelessly on your projects over the past couple of months, over 10 or more sessions. And so we're super excited to celebrate and listen to all of your work today. We have 5 students presenting today on a variety of different topics, and a fellow member of our Polygence team will be scoring each student's presentation, and I think she's actually online, which is great. And the scoring will help us determine prize winners after the event, so stay tuned for that. If you have questions, please type them in the Q&A, and we will go through questions for each presenter after their presentation instead of waiting all at the end. So if you have questions during the presentation, throw them in the Q&A and then I'll moderate the discussion afterwards. Today we have 5 speakers: Eli, Divya, Hailey, Youssef, and Whoba. And super excited to hear all of your work. And so the first up is Eli. So Eli, excited to hear your presentation. If everyone else can turn off their cameras and mute, and Eli, I'll spotlight you and feel free to start sharing your screen whenever you're ready.
Okay, hello. My name is Eli Newman. Here we go. All right, so my project is a mathematical model of azathioprine and allopurinol for autoimmune hepatitis. Okay, so why did I choose this project? Well, autoimmune hepatitis is a particular import to me because it's a disease that I have, and the treatment plan that I'm going to be discussing is the experimental treatment plan that was given to me, and it helped put my disease in remission. So what is autoimmune hepatitis, or AIH for short? Well, to start with, we have to discuss what an autoimmune disease is. And an autoimmune disease, very simply, is just when the body attacks a part of itself. AIH is when this happens in the liver. And AIH is mediated by T cells in the immune system. And T cells, for those that don't know, are just the soldiers of your immune system. They help fight off invaders. But it's good to know that AIH can be fatal if left untreated, so it's really not a joke. It's because AIH is mediated by T cells, treatment plans are usually attempting to inhibit those T cells. And the most common form of this is the use of prednisone in conjunction with azathioprine. Prednisone is a steroid, and it calms down your immune system. Azathioprine is a purine blocker, which inhibits the production of T cells. So what's the problem? Well, azathioprine doesn't work for everyone. Some patients have a reaction to the drug, meaning that an alternative treatment plan must be used, 2nd-line or 3rd-line therapies, and some patients don't respond at all to the drug, or even end up with more liver damage as a result of taking the drug. And this case is what this presentation is going to focus on. So why do some patients not respond to azathioprine? Well, it's important to notice or to know that azathioprine is a prodrug, which means by itself, it's inert. It doesn't do anything. It's only therapeutic once it has been converted into the metabolite 6-TGN, which is active. And this will become important later, so I'm going to say it now. But therapeutic levels of 6-TGN range from 235 to 450 pmoles per 10 to the 8th red blood cells. And as you can see, this metabolic pathway of azathioprine is quite complex. The metabolic pathway diagram, or the figure, is here. And different levels of enzymes can change the metabolism of the drug. So for example, if you had too much of the enzyme xanthine oxidase, which is in red, it's the thing that's in the square, too much of the azathioprine will be turned into 6-TU and not enough into 6-TGN, and the patient won't respond to the treatment. In the worst case, azathioprine can also cause more liver damage. When azathioprine is preferentially metabolized towards 6-MMP, this can be problematic because 6-MMP is a metabolite that's associated with hepatotoxicity, which is just a fancy word for liver damage. And this happens if there's too much TPMT present. And again, this will become important later. So I'm going to say that hepatotoxic levels of 6-MMP are levels greater than 5,700 pmoles per 10 to the 8th red blood cells. So how could allopurinol fix this? Well, allopurinol is a drug that inhibits xanthine oxidase and TPMT, forcing more azathioprine to get metabolized into 6-TGN, which is the therapeutic metabolite. If we look back at the diagram, if we cut off XO and TPMT, all of the azathioprine is forced to become 6-TGN. And it's important to note that this mechanism of action is not entirely understood. And it also must be done very carefully, mixing allopurinol and azathioprine, that is, because too much 6-TGN is no longer therapeutic and can cause something known as myelotoxicity, or also known as bone marrow suppression, which is not something that you want. And this use of allopurinol with azathioprine is not optimized at all, really, because it's just not used often enough. And the complexities between what's going on, it's quite complicated. So to try to better understand how to optimize allopurinol's effect on the metabolization of azathioprine, I created a system of differential equations reliant on Michaelis-Menten kinetics to model the metabolites. So I started with this metabolization figure, and from it, I was able to derive all of the system of differential equations. All right. So for those that don't know, Michaelis-Menten kinetics is just a model for reactions involving enzymes. It's where you see all of these Vmax times M over Km plus M, all those terms like that. Those all come from Michaelis-Menten kinetics. And each equation is gotten from the flow, the quote unquote flow, on the metabolization diagram. So if we look at 6-TGN, we notice that what's flowing into it is 6-TXMP. And that's shown in the differential equation by that Vmax G times M over Kmg plus M term. And you also have an arrow pointing away from 6-TGN, which represents it being or leaving the body. And that's represented by the minus D6G term. And so with the system of differential equations, 2 simulations were run to represent hypothetical scenarios. The first scenario is one in which the patient has a normal metabolism of azathioprine. The second scenario is one in which the patient has an abnormal metabolism of azathioprine. So in this first simulation, it's important to know that azathioprine dosage is kept constant throughout. What's actually changing is the dosages of allopurinol. And so each curve in here corresponds to a different dosage, and the dosages are in the legend here. And what we're actually measuring are 6-TGN and 6-MMP. Recall that 6-TGN is a therapeutic metabolite and 6-MMP is the hepatotoxic metabolite. And the red lines show the thresholds for where we want those metabolites to be. So for 6-TGN, we want it between these 2 red lines. And for 6-MMP, we want it below the red line. And I also want you to notice that in the middle of the page, we have our table. And this will become a little bit important next slide, but just know that the Vmax-T for now equals 15. That's the only thing that will change ultimately. But the only line that gets us to where we want to be is the blue line, which corresponds to no added allopurinol, right? It's the only line that is both below the hepatotoxic line for 6-MMP and is also in the therapeutic range for 6-TGN. And this is consistent with what we know. Somebody who has a normal metabolism, they don't need allopurinol. All right, so remember that Vmax-T equals 15 term? Well, we multiplied it by 5. And this corresponds to a shift in the metabolism from a normal metabolism to an abnormal metabolism. And now everything else is the same. But now when we look at the 0 milligrams of allopurinol curve, we notice that it is well above the hepatotoxic range, or it's in the hepatotoxic range. And we also know that looking at 6-TGN, it is well below the therapeutic range. And what we find is that these 100 milligrams, this brown line, when we add 100 milligrams of allopurinol, it gets us to where we want to be. Look on the 6-MMP graph. It is well below the hepatotoxic range. And if you look at the 6-TGN graph, I'm not sure if you can see my mouse, but it is snugly inside the therapeutic range for 6-TGN. This is also consistent with what we know. When allopurinol and azathioprine are prescribed for AIH, 100 milligrams is a pretty standard dose. So in conclusion, this model is a good start to understanding how to optimize an azathioprine and allopurinol treatment plan. And this would be invaluable to people like me who have autoimmune hepatitis and who don't respond to azathioprine by itself. In the future, if these parameters can be tailored to an individual's metabolism, this model could become the basis of creating a personalized azathioprine and allopurinol treatment plan. I'd like to give a special thanks to my mentor, Archie. Without him, I would not have been able to complete this project. And thank you for listening.
Thank you so much, Eli. What a personally motivating and personally relevant, topic for you. As people start writing questions in the Q&A, I'd love to first understand actually how and if this research has actually changed your own relationship with the condition, as well as whether it sort of informed you a little bit more about how to live with it.
Yeah, absolutely. So for me, I was diagnosed with autoimmune hepatitis when I was pretty young. So I wasn't really sure what was going on. I was just kind of, taken from place to place, given whatever I was given. I took whatever medication I had to take. But now, for the first time, I actually feel like after this project that I truly understand like the mechanisms of my disease and the treatment plan that I took, which is a very cool thing to be able to say.
That's so awesome. We have a question from Stacy, which about one of your graphs. So in simulation 1, it kind of looks like the curve for 6 MMP and 6 TGN have slightly different shapes. If you want to pull up and just share your screen again for the simulation 1. Specifically, 6 TGN starts exponential and then tapers off, while 6 MMP looks logarithmic from the start. Is that right? And if so, any thoughts as to why?
So that's a very difficult question to answer because we're dealing with a system of differential equations. I'm not sure how familiar everybody here is with differential equations, but they're notorious for being complicated. It just has to probably do with the parameter values, but there's some sort of mechanism that's going on like inside the equations in that pattern. But I don't know like the exact parameter value that's causing that change. So sorry for the slightly not so informative answer, but the truth is it's probably a couple of things that are causing that shape. But it does look, I agree, it does look exponential and logarithmic.
Amazing, thank you. Awesome. Any other questions, either from other presenters? Divya had a question. Could you expand on what you see as the future of treating this disease and sort of what future research you're particularly going to be looking out for?
Yeah, so especially in this case, what I'm hoping is that as science develops, we get a better handle on these parameters. So a lot of this relies on these parameters, all of these like letters that you see. We don't know most of these right now. And I think that if we could start to understand like what these parameters are and how they differ from person to person, we could create more personalized treatment plans, especially for this situation where people don't respond to azathioprine.
Amazing. All right, in the interest of time, we're going to move on. Thank you so much, Eli. Next up is Divya. So I'll turn off my camera, and Divya, feel free to turn on yours and share your screen. Okay.
Just let me know if you can see my screen.
Yep, all good.
Okay, sounds good. So the title of my project was An Examination of Habitability in Exoplanet Systems. So as you read the questions on this slide, think about the possibility that they gave way to, the curiosity and inspiration they may spark. These profound questions are what inspired me to write my paper. The idea that I would be able to explore these questions, even in the slightest, was extremely exciting. I hope that you all share this inspiration and keep it in mind as I further discuss my paper. So I want to start with a short background of my topic. Exosolar systems are solar systems other than ours, and they contain exoplanets, which are planets other than ours. I chose to focus on Kepler-62 and TRAPPIST-1, two exosolar systems with promising exoplanets. By compiling a variety of data, observations, and predictions, I determined the most likely habitable planet in each system. An important reminder to this is that the life that we know of is not yet well constrained, and the definition of habitability is also not yet well constrained. Because we only have experience with life on Earth, we see habitability through a filter. And this does limit our definition of habitability and our likelihood of finding life in the long term. In this paper, we consider a planet habitable if it has a solid surface, reasonable climate conditions, is capable of hosting liquid water, and has retained an atmosphere throughout its formation. So there were 5 main sections of my paper. How and why Kepler-62 and TRAPPIST-1 were selected, the parameters used to rank these planets, results and discussion, comparison between systems and to Earth, and conclusions and final takeaways. So how and why Kepler-62 and TRAPPIST-1 were selected. Kepler-62 had 5 planets. Planets E and F were in the habitable zone and had reasonable predicted temperatures. Overall, it was a well-studied system with an extensive amount of predictions, models, and values made upon it. TRAPPIST-1 had 7 planets, the inner 6 of which are believed to be rocky. TRAPPIST-1, E, and F are in the habitable zone, and it also had an extensive amount of research, models, predictions, and values available. So the parameters I used to rank the planets were planet density, which was derived from the mass and radius of the planet and helps reveal whether a planet is rocky. Obliquity is the degree of tilt to a planet used to predict environmental conditions such as wind patterns, seasons, and variations of temperature. Temperature is essential to determining if liquid water can exist. Water is a versatile and key molecule for many life-sustaining reactions, and temperature plays a large role in its presence on a planet. Semi-major axis is the distance from a planet to its star, and this has an impact on the temperature of the planet. Atmosphere, or the climate, is also important for life as it protects the planet from extreme temperatures, harsh radiation, and creates adequate pressure, as well as keeping in vital gases. Overall, any information found on the planets was used. When determining habitability, it is important to know every detail possible about a planet. So we searched a variety of papers and studies to obtain any information that would be useful. So on the right here is a table that I included in my original paper, and it ranks the planets in the Kepler-62 system by habitability of each parameter. So as you can see, planets E and F are highest ranked for all categories, so we focus on those two planets. Planet E has reached pseudosynchronization, which means only one face of the planet is shown to the star for most of its orbit, making both sides either really very hot or very cold, which creates a hostile and extreme environment. Kepler-62f has an obliquity close to Earth, producing similar wind patterns and climate as the one that we know on Earth. Therefore, Kepler-62f was decided to be the most habitable planet in the system. TRAPPIST-1, so on the right here is a table that was also included in my original paper ranking the TRAPPIST-1 planets. TRAPPIST-1 E and F are most similar to Earth in terms of temperature and semi-major axis, and the two have reasonable densities, so we focused on those two planets. They both have lower ion escape rates. Ion escape rates is the rate at which ions and molecules escape the atmosphere throughout time. Having a lower ion escape rate increases the planet's ability to retain an atmosphere, which is essential to habitability. With this criteria and some extra information, TRAPPIST-1e was found to be the most likely habitable planet in the system. So I next compared the systems to Earth and to themselves. So in terms of host star, the two host stars have their differences, but because we consider a variety of other qualities in this paper, size and temperature of the stars are not too important. Atmospheric properties. Because the Kepler-62 planets have obliquities or degree of tilts around or less than that of Earth's, they likely do not have extreme wind patterns and temperatures. There was not much information on the atmospheres of the TRAPPIST-1 system. Radiation from the host star. In terms of non-thermal radiation, the TRAPPIST-1 planets all receive some amount of strong X-ray and extreme ultraviolet radiation. TRAPPIST-1d, E, and F have some chance of retaining water, but the others are dry because of this radiation. Kepler-62 does not emit radiation in such problematic amounts. Finally, expected formation mechanism. The TRAPPIST-1 planets likely formed further out and then migrated inwards to their current positions, the two inner planets moving in separately from the others. The formation history of the Kepler-62 planets, however, is not yet well known. Finally, a comparison between systems and to Earth. So Kepler-62f and TRAPPIST-1e were the most likely habitable planets in their solar systems. Both are in conservative habitable zones, which means the zone in which liquid water is most likely to exist. Both have agreeable atmospheres that would maintain good weather, and both have eccentricities close to zero, meaning they experience minimal heating variations over their orbits, less extreme variations in temperature. Their differences is that they have varying temperatures and varying radius or size of the planet. However, all things combined, the two planets are relatively more similar than they are different. Kepler-62, compared to Earth, is cooler at 208 Kelvin instead of 255 Kelvin. It has an obliquity close to Earth's, however, meaning similar weather and seasonal effects. It also has a rapid rotation period, 20 to 40 hours, which indicates stronger wind patterns, and overall is predicted to have very Earth-like weather. TRAPPIST-1e is very close in temperature and is predicted to retain an atmosphere, which is an important component of life on Earth. However, its atmospheric makeup, or the gases in its atmosphere, is not yet well known. Finally, conclusions and final takeaways. Despite the similarities to Earth, there are still very few exoplanets discovered so far that have resembled any of the planets in our solar system in terms of orbital period and planet mass. As you can see in the table created by my mentor in the center of this page, so the table contains all of a majority of the exoplanets currently confirmed to exist, plotted as a function of planet mass and period. As you can see, the planets in our solar system are plotted as well. However, none of the other exoplanets are close to it. We are likely not yet capable of finding exoplanets exactly like our solar systems in every sense, and the ones we know of are only the ones close enough to Earth and visible enough for us to observe. Therefore, there are consistent limitations that render us incapable of finding other more distant planets. In terms of future missions, the TRAPPIST-1 system is much closer to us than the Kepler-62 system. Because of this proximity, TRAPPIST-1 is scheduled for further characterization by JWST, which is a space mission launched in December 2021. The Kepler-62 system, however, is much harder to observe because it is farther away, and so it is also harder to explore habitability on. Finally, biosignatures are certain molecules that are used when searching for the potential of life. These molecules are present in a variety of life or are often markers that indicate the likelihood of life. They include PH3 phosphine, CH4 methane, and CH3Cl methylchlorine. The presence of these molecules and other biosignatures serve as convincing evidence to some form of life or type of organism inhabiting the planet. Thank you.
Thank you so much, Divya. So exciting to be thinking about whether there are other life forms on other planets. As we have people typing in the Q&A for questions, I actually have a rather provocative question, which is the parameters that we've chosen, that you and your mentor have chosen for looking at, the conditions of other planets, assumes that life would be similar to what life looks like on Earth, right? Have there been studies on or hypotheses explored on what if life took a totally different form, right, on other planets? Meaning the telltale signs of life, whether it's the methane molecules or the other molecules that you were mentioning. What if we're looking for the wrong thing? What if life on Earth is sort of just one form of what life can look like? Does my question make sense?
Yes, no, it does make sense. And yes, there has been. So there actually are a type of organisms on Earth called extremophiles, and they exist in very extreme hot environments or cold environments or just environments with extreme qualities. So there has been studies on trying to find life based upon these type of extremophiles because they exist in more extreme environments that we're not used to. However, we did choose to focus on life as we know it because it is, number one, the main reason was because there's a lot more research on it, and it would be a lot easier to go more in depth and get more definitive answers.
Awesome, super helpful. Any other questions, whether from audience members or attendees or presenters? I actually have one more about how you got interested in this. I mean, I think all of us have at some point imagined or like read sci-fi novels or watched movies about it. But what made you interested enough to like do a whole project on something that's so complicated and difficult?
Yeah, so I definitely agree. I mean, I've been interested in this and also the questions presented at the beginning of my slideshow for a long time. And I really wanted to delve into them and, discover their complications and their implications and how we would look for life, which is such, a big topic and it's such a complicated topic and it could take forever to, talk about and explore. So I really wanted to, learn a little bit more and get my feet more wet in the topic.
Totally. Love it. All right. Thank you so much, Divya. We'll move on to the next presenter, who is Hailey Connett. I'm super excited to hear your presentation, and I'll come back on when you have 1 minute. So Hailey, feel free to share your screen. You may need to unmute yourself. Yeah.
Okay. Hello, I'm presenting on the early detection of obsessive-compulsive disorder through behavior and genetics. And I decided to choose this topic because I have several family members who have been diagnosed with obsessive-compulsive disorder, and there's a lack of treatment for them, and therefore they are really struggling with the disorder. Recent estimates suggest that 2 to 3% of the population has been diagnosed with obsessive-compulsive disorder. OCD is a mental health disorder that consists of obsessions, which are persistent and distressing thoughts, images, doubts, or urges, and compulsions, which are inferring and ritualistic mental or physical behaviors the individual feels compelled to perform in order to alleviate distress and/or prevent negative outcomes. Current treatment options consist of cognitive behavioral therapy, exposure and response prevention, and serotonin reuptake inhibitors, and antipsychotics. However, these treatment options are insufficient. This is seen through a meta-analysis that show that although the majority of adults taking SRIs had a complete recovery, some had symptom improvement, very few had a complete recovery, and 24 to 89% relapsed. In children with OCD, the treatment effect size was significantly lower than it is for adults. Studies have shown that the longer a disorder is not treated properly, the worse symptoms get, and the likelihood of treatment resistance increases. Therefore, early detection of obsessive-compulsive disorder will allow for sooner and more effective treatment. I will discuss the different options for early detection. Real-life events can trigger specific obsessions and compulsions, including contamination fears, avoidance behaviors, rituals, etc. Family members who know that OCD runs in the family can look for various environmental triggers, but ultimately rely on obvious behavioral changes for diagnosis. A study of individuals from the Swedish National Patient Registers found that 44 to 40% of OCD risk is due to genetic effects. The table and the study signify that OCD is genetic. Studies have shown that shared environmental factors have little importance, while non-shared environmental factors have found to be very significant. Shared environmental factors are experiences that siblings share and generally occur inside the household. For example, a divorce or the parent's parental style. Non-shared environmental factors are experiences that siblings do not share, such as having different friends or different teachers. One study found that non-shared environmental factors make up 51% of phenotypic variance in obsessive-compulsive behaviors, while shared environmental factors did not make a difference. However, non-shared environmental factors can only be loosely used in early detection, as they are correlative and not causative. There are numerous genetic mutations that have been found to be correlated with OCD. You can see this in Table 1 that I included in my research paper. However, there is no direct causation between any of the identified genetic mutations, only correlations. 2 genome-wide association studies have been conducted. These studies study the entire genome, which allows scientists to identify specific genes associated with the disease or trait. The International OCD Foundation Genetics Collaborative conducted the first genome-wide association study. This study found 2 single nucleotide polymorphisms located in DLGAP1 were connected to OCD. 400 trios that were consisted of a proband and both parents were studied in the same study. A proband is the first person in a family to receive testing or diagnosis for a specific genetic disease. There were no genome-wide significance found. It can be hypothesized, however, that genetic variants are not located in the parents of probands, which is why there are no genome-wide significance in the trio study. However, that does not mean that OCD is not genetic, considering that probands are the first person in their family to be suspected of inheriting a certain disorder, and their parents do not need to be the ones with the disorder. The other genome-wide association study conducted was by the OCD Collaborative Genetics Association study, had a total of 5,061 people that consisted of 1,065 families that had a total of 1,406 people diagnosed with OCD, and the rest were controls. The most significant gene found was the gene encoding PTPRD. Then PTPRD encodes for protein tyrosine phosphatase, which oversees cell growth, differentiation, and mitotic cycle. This means that it likely plays an important role in early neuronal development and synapse formation. Life experiences can directly alter gene expression via epigenetic changes, sometimes increasing disease risk. Genetic changes are when the protein made is altered, while epigenetic changes affect the genes that are actually expressed. Studies have found that patients who have OCD are more likely to have a form of childhood trauma than people without OCD. Other studies have suggested that childhood trauma may cause epigenetic changes in monoamines oxidase, A/B, and catecholomethylferase genes, leading to OCD. COMT is involved in the degradation of dopamine, epinephrine, and norepinephrine, which are neurotransmitters. MAOA also plays an important role in the breakdown of dopamine, serotonin, and norepinephrine. Mutations inferring with the degradation of these neurotransmitters likely contribute to the behavioral changes that are linked to OCD. It can be concluded that childhood trauma is correlated to OCD by altering the expression of these specific genes. There are numerous parts of the brain correlated to OCD and that possibly cause OCD. Knowing the neurobiology of OCD along with brain imaging can detect OCD early on. The scan will notice irregularities, which will signal that the individual has OCD or is likely to develop OCD. The greatest correlation is a dysfunction in the corticostriatal thalamal circuitry. A small activation of the frontal parietal circuitry causes a greater amount of activity in the direct pathway instead of in the indirect pathway. As a result, there is hyperactivation of the orbitofrontal subcortical pathway, leading to exaggerated worries about various things, which is seen in the figure right there. Then behavioral testing. Professionals use the DSM-5 to diagnose OCD. It's a manual that contains criteria for a specific mental illness to be diagnosed, and then these criteria is located in table 3. However, symptoms need to be present for the DSM-5 to be used. A detection before behavioral symptoms is beneficial because it allows for a better course of treatment. Biomarkers are measurable indicators of disorders. A well-known biomarker is blood pressure. Several biomarkers are correlated to OCD as seen in table 4. However, many studies suggest that it is unlikely to find one biomarker for one disorder. Therefore, biomarkers are useful in detecting disorders, but not OCD specifically. And concurrently, there's nothing used to detect OCD early on, leading to detection only when symptoms are present. As a result, it is more difficult to have effective treatment where symptoms are lessened or even completely gone. Not only is successful treatment difficult, but milestones are also missed. Discovering the options of early detection allows for OCD to be diagnosed before the complete onset of the disease. As a result, treatment will be facilitated before symptoms are present and will be overall effective. And I believe that the most important options or most useful options are fMRI scans, which will detect any neurobiological irregularities, or a genome-wide scan, which will detect any sort of genetic variations. Thank you so much for listening, and I would like to shout out my mentor, Alicia. I could not have done this without her. Thank you.
Thank you so much, Hailey. This is so interesting. I too have a lot of friends and family members who suffer from OCD, and it's always been sort of a question on my mind, like, is it genetic or is it really wholly just sort of nurture? And I was wondering, have there been studies on sort of whether the type of OCD, meaning is it washing hands, is it something else, is encoded in the genes, or is it more just, or do those genetic markers mostly encode the tendency towards obsessive behavior, but not necessarily the type of behavior, if that makes sense?
Yeah, I get what you're saying. There has been many studies on it. One study specifically studied like the neurobiology of it. I did not get to that part of the presentation. That was running out of time, but it showed that there was different parts of the brain that were connected to OCD behaviors. So like washing rituals and different type of known like OCD rituals were connected to different parts of the brain rather than genes. It was more all brain circuitry.
Interesting. We have a question from Divya. I noticed that you said certain behaviors are connected to certain parts of the brain. Does this have correlation to certain types of manifestations of childhood trauma? In other words, do different types of trauma induce different OCD behaviors? That's such a cool question.
That is a really cool question. One thing is that gene environment interactions have really not been fully studied in OCD. They're actually the last one that has been studied was in 2016. So there are not really many developments in that area. So it is difficult to say if childhood trauma causes specific behaviors because that area of OCD really has not been studied yet.
Awesome. For time reasons, I'm going to move on, but there's another question from Ali that I'll DM to you, Hailey, so that you can answer. Great. Thank you so much, Hailey. Next up, we have Youssef Abdelhalim. Very excited to have him present. So I'll come back on at 1 minute, and if everyone else can turn off their cameras, that'd be great. Youssef, take us away.
All right, let me share my presentation real quick. This work?
Yep, we can see it.
All right, perfect. Hey guys, my name is Youssef Abdelhalim, and today I'll be presenting my project, which is called TitanWandelaar. And I'll talk more a little bit later about why I named it this specifically. And yeah, let's get started. So before I explain exactly what my project is, I want to give a little bit of background. This project revolves around Mars rovers, or just rovers that nest sense to other planets and extraterrestrial surfaces, just to examine the surface. And it's more so about the dynamics of these rovers. So the current suspension system that that NASA uses is called the Boogie Rooker suspension system, which is shown in this GIF here. And it's been used since the 1980s, and it's a really, really stable suspension system. And one of its biggest features or biggest advantages, as you can see, like both sides of the rovers do not really have to be on level surfaces. It's super, super flexible. So if the right side goes over a rock, it's fine. It will, the center of mass will still remain stable, which is why this is a really, really superior design. Like if you think about this compared to a car, if a car like goes over an obstacle on the right side, like the entire car will like shift off balance or like tip over. So this is why they use the Rooker Boogie system. And it they don't even need any springs on it, which simplifies it even more. You just need like a central differential, and that's about it. So there's been a few problems with this design that that haven't been addressed. So one of the biggest problems is that it doesn't really help much with allowing rovers to move on sandy or like coarse surfaces. And also it doesn't really do anything to prevent wheel erosion from jagged surfaces, because if you're walking on if it's like traveling on a rocky surface like Mars, there's going to be a lot of rocks, a lot of like pebbles, all these things. And there isn't really anything to address this, because these wheels aren't rubber like car wheels. They're like made of metal, right? So it's like two hard surfaces hitting each other. So two instances where these problems actually, where we actually saw these instances happen was in 2009 on the Spirit rover, uh, which which is the picture on the left. It got stuck in a sand trap on Mars, and it got decommissioned, and it was $800 million. So that was a lot of money wasted just because of a silly sand trap. And the picture on the right was a picture of the wheels on the Curiosity rover, and it's fully eroded, and we're still trying to figure out how we are gonna go about it, fixing that and making it still functional for a long time. So yeah, these are two of the biggest problems that we've seen with the Rooker Boogie design, and NASA has decided to ignore them because it mostly works. It has like these little hiccups, but there's already been a lot of resources put into furthering this design and making lots of different variations and models of it. So they kind of don't want to move away from this model. So this is where my project comes in. So my project relies on mechanical walkers, and these two gifts on the bottom kind of show like two really common types of mechanical walkers. So the one on the left was developed by a Dutch engineer and artist. His name is Theo Jansen, super popular, and this design specifically is really well known. It's called the Strand Beast, and it was actually invented to prevent sand from washing away into the ocean, and so it keeps the sand coming back inland. So so it like kind of stays high inland, and it just prevents from it just makes sure that the land isn't getting too low for the water to wash up and keep getting into like too far inland. So this was the whole reason this exists, and it works completely automatically. It doesn't walk into the sand. It has mechanisms that prevents it from walking into the water. And the one on the right was it's called the Strider linkage, and it was researched a lot for being used in tanks, like army tanks. And so mechanical walkers are really good because they allow you to walk on like sandy surfaces, as you see on the left, and also rocky surfaces. Now the problem is there isn't really any mechanical walkers or 4-bar linkages that allow you to walk on both of these surfaces as well as an inclined surface, which is something that you can see a lot on planets. So this is where my project starts. So I first had to design a 4-bar linkage that allows you to that had to do 3 things. So the first thing was allow it to walk on a sandy surface, a rocky surface, and on an inclined surface. So this was the 4-bar linkage that I was able to design. And the way a 4-bar linkage starts, or a mechanical walker starts, is you start with a normal 4-bar linkage. So this is what it would look like. So you first design the 4 bars, and depending on the ratios of the side length, you can either get a crank rocker movement, a crank crank movement, or a rocker rocker movement. And to explain this real quick is, so this specifically is a crank rocker movement, and you can tell because this one cranks. Like a crank means it moves in like a full revolution, and rocks means it oscillates. So this cranks and rocks. So there could be a different one that rocks, and so both of them oscillate, and there could be ones that that crank, so both of them do full revolutions. And after you do that, you kind of like add in like however many side lengths you want to create that locus or that desired footpath. So that desired footpath was developed using a Mathematica code, which tells us basically what the desired foot shape is that allows you to do the 3 things that I mentioned earlier. And choosing the side lengths was kind of like a guess and check to be able to get that shape that we wanted. So this is a SolidWorks model of just one leg, just like a pair of legs working together on the crankshaft and the main body. And so this design allows for movement on sand, because mechanical walker just allows for gliding. And you can also, it allows for walking in rocks because the cranks are the crankshaft is separated by 100 degree. It's 120 degrees of phase, so it allows for moving on rocks, and it also allows to climb on inclined surface because of the shape of the locus itself, or like the footpath. So this is a short video of the full model. This animation was created on SolidWorks. So this is basically everything when it comes together. So the top box is what houses all the electronics inside of it and the motor. And yeah, so this is the circuitry that powers the whole thing. It has also a temperature sensor and a humidity sensor, basically all the small electronic systems that would be on a rover, just to simulate that Mars experience, or the rover feel, that rovers to emulate the function that rovers would do in space. And this is just a schematic for the circuit. And one of the biggest innovations here with this project is that we can actually choose where there's more material by using additive manufacturing. So this design, the way I created my models, allows us to use additive manufacturing, which is basically just metal 3D printing. And by using finite element analysis and stress analysis and topology optimization, you can figure out where certain parts need more material because there's a lot more stress, and certain parts don't need a lot of material. So you can just decrease the density of the material. And that creates a really, really high stress to weight ratio. And by doing that, you can, so like the feet would feel a lot of stress because they're always like hitting on rocks. So you can have the density there be like 100% filled in. But in parts of the frame where there isn't a lot of stress or a lot of movement, you can decrease that density. And by doing that, you can prevent issues where the wheels would get eroded, because the way the wheels are designed right now, they are meant to be thin. So if we have feet that are fully dense, it's not really going to break the same way the wheels on the rovers that exist right now break. So this is how my design addresses these 2 issues. And yeah, also one more thing that I forgot to mention, The legs also allow for a really like a way wider margin of error, because in my design there are 12 legs, and this means that all of them could break except two pairs of legs, and it would still be completely functional, and that would increase the longevity of the rover. But yeah, this is all I had to say. Thank you so much. And if you want to read more about my project, I have like a 120-page report. It's on my Polynet page, so you can read more about my design choice and all these things. But yeah.
This is amazing. Thank you so much, Youssef. So in the interest of time, I'll ask one question, and it's actually two questions wrapped into one, and then we'll move on to the next one, but amazing work. So we have a question from Lucy and Stacy that are both kind of related, which is, you mentioned that the Mars rover has corroded. I would think that this means that the material that's used is chemically incompatible with the environment on Mars. Do you know what material was used, and what would be an ideal material for a Mars walker?
So it's not about the material itself, it's about the fact that they made it like thin enough so it's super lightweight and could move on the so it just could move. So it's not the fact that the material itself is bad, it's just that they made it thin enough that it's not dense. So when it comes in contact with rocks a lot, it corrodes over time.
Got it.
But the ideal material that I made a material selection in my paper, and it was titanium aluminum 64, and that's because it's really widely used in additive manufacturing, and it's also really strong while also being super lightweight. So yeah.
Great. Thank you so much, Youssef. All right, last but not least, we have Whoba. And I'll ask everyone to turn off their sound and video except Whoba. So Whoba, all yours. I believe you're muted.
Yeah, okay. So I'll be presenting my research project, which is just a comparative study on traditional and modern dental practice. So as the name implies, it's on like in the dentistry field, and it's on oral hygiene. So to solve a problem, you need to first identify the problem. So many studies have shown that the human oral cavity harbors a complex microbial community of diverse range of microorganisms, which comprise of several bacteria, fungi, and protozoa. So firstly, you need to understand that the problem is dental caries. And what is dental caries essentially is the damage of a tooth when decay-causing bacteria in the oral cavity produces acids that erode the tooth enamel. And another problem that is faced in the oral cavity is periodontal disease, which is essentially a serious gum infection that damages the soft tissue as well as the bone supporting the tooth. Some common bacteria, just to name a few, are Streptococcus mutans and Staphylococcus aureus. So what is tooth decay? Tooth decay essentially is the damage of the tooth due to the production of lactic acid when there's an accumulation of bacteria on the enamel. This happens when you eat and you don't properly brush your mouth, and so this bacteria accumulates on the enamel and produces what is known as plaque. When this happens, they react with the saliva and sugars from the food that you eat, producing lactic acid. This in turn causes the erosion of the enamel, because the increase in lactic acid causes a reduction in the pH level. And so the major component of the enamel, which is the outermost layer of the tooth, which is hydroxyapatite, decomposes. And so this leads to the erosion of the enamel. And when this happens, it leads down because it causes oral cavities, which are essentially the holes that you see in teeth that are not taken care of. When this happens, it leads to the erosion of dentin, pulp infection, and eventually, after traveling down the pulp canal, it leads to abscess formation. So the conventional solution, the solution we're all aware about, is the use of toothpaste and toothbrushes. According to American Dental Association, toothpaste is a gel dentifrice, which essentially removes dental plaque and food debris, suppresses halitosis, which is essentially just a condition categorized by foul-smelling breath, and it prevents tooth decay and gum disease. And essentially, toothpaste contains about 20 to 42% water and is derived from various components, which may include abrasives, detergents, and fluorides. Also, some toothpaste have been shown by studies to contain triclosan, which is essentially just an antimicrobial agent. However, there's been an increase in antibacterial resistance to antibiotics that are not only used in oral hygiene, but in all forms of antibacterial practices. And so, there is a need for a new form of, like a new solution and a new intervention. And this comes in the form of chewing sticks. So many countries that have like tropical climates, for example, Nigeria, which is where I'm from, studies have shown that they have climate that encourages the growth of more than 65,000 species of plants, which are shown to have medicinal properties. Now, these plants that have these medicinal properties range from, oral hygiene to anti-diarrhea medicinal plants. And so, but the one I'll be focusing on are the plants that are used in oral hygiene, and these are known as chewing sticks. So chewing sticks are essentially made from the roots, twigs, and stem of a plant, and they can vary from around 13 to 30 centimeters long and are tied in a bundle. And how it's used is basically how you use your toothbrush. The only difference is that there isn't a toothpaste, that comes with it. So essentially you just chew like any end of the stick and you use it to brush your teeth, as you can see in the picture here. Essentially, there have been a lot of studies that have doubted or shown some level of doubt towards the relevance of chewing sticks, because many researchers believe that what gives a chewing stick its effectiveness is just the fact that it has like the mechanical action of chewing the stick, and so that removes the plaque, which to an extent is true. But certain studies, such as one carried out by Olson in 1978, on chewing sticks found and used in Ethiopia by Ethiopian children, has been proven to be as effective as toothbrush. And also a study by Dr. Alan Davison from the University of Newcastle has also shown that some chewing sticks have fluoride concentrations ranging from 2.3 to 17.2 micrograms per gram. Also, the International Conference of Healthcare in 1978 and the WHO resolution of 1989 has urged, members of state and countries as well to introduce measures in regulating and controlling, as well as integrating medicinal plant products into the public health industry. So my thesis origin. So growing up in the city, I never used like these chewing sticks. I was only told about it by my grandmother, who, grew up in these traditional regions in Nigeria. And so I was really interested in, such ancestral practices being relevant even in modern times, despite the discoveries made in modern day dentistry. So it made me wonder if, these practices were maintained because of the trying to retain the culture, or because of the economic instability of Nigeria, or could there actually be natural antibacterial compounds in these chewing sticks? And so what encouraged me and pushed me to actually pursue this project is that I personally, I endeavor to, engage to, have an occupation in the pre-health field. And so I saw this as an opportunity to explore, the health sector. And also, it also gave me an opportunity to incorporate my culture into the health sector. So initially, I was going to plan a research paper in which I collect primary data from commonly used chewing sticks in Nigeria and against commonly known oral bacteria, and just test for the susceptibility of the bacteria through zone of inhibition, minimum inhibitory concentration, and maybe see if there's like a synergetic property between the sticks and the toothpaste. Unfortunately, I was not able to do this as an international in the States, and so I had to take a different approach, which came in the form of a literature review. So for the literature review, I used the PRISMA guideline, which is essentially just a guideline that helps in writing systematic reviews. And my research question was made using the PICO strategy, which is essentially population intervention, comparators, and outcome. And it came in the form of, is our chewing sticks, as a chewing stick beta cola, more effective in inhibiting pathogenic oral bacterial growth in humans when compared with toothpaste? The database that I searched were PubMed, ResearchGate, and Epistemonicus, that's a very complicated name, and the registers that I used to make sure that my replicating another review were clinicaltrial.gov and Prospero. So the strategies that I used in searching for these data included keywords in using the Boolean operators such as and or in these databases, such as, typing in chewing sticks or chewing sticks, with the emphasis being the S, because some research papers specify. And there were some eligibility criteria that, I used in including and excluding studies. Some inclusion criteria were that the studies had to be, had to have a primary outcome where they measured the zone of inhibition or they measured the minimum inhibitory concentration. Some of the studies had to have the Garcinia cola, which is a common chewing stick in where I come from. And also because of some literature was written in our traditional language, literature wasn't limited to only being in English. Because I come from these regions where, these research papers are written, I was able to translate some of the literature into English, for which I was able to use. So there were there was a lot of literature. I mean, there was relatively enough literature to write a review, but just a summary of the literature, a study by Amulu showed that ethanol-based extractions of Garcinia cola had zones of inhibition of Staphylococcus aureus, which range from 0.5 millimeters to 5 millimeters, and against E. coli range from 0.3 to 3.2 millimeters. Whereas a study by Anyam showed that close-up toothpaste, as we all know, like a commonly used toothpaste around the world, was tested against E. coli and Staphylococcus aureus, and yet it did not show any significant activity against the E. coli. And the mean zone of inhibition against the Staphylococcus aureus was only 5.5 millimeters. So, I would have gone more into depth with some of the literature, but because of time, I'll move on. So the conclusion and recommendations. So considering the findings of this research, it is therefore necessary to conclude that, this chewing sticks could be on par with the toothpaste and toothbrushes seen in the literature. So there is a need to investigate the antimicrobial potency of these plants against a wider range of clinical isolate bacteria, and to obtain a more accurate evaluation of this plant's therapeutic, potential. There's also a need to, elucidate the mechanism of action and chemical components accessible in these chewing sticks. The only problem and setback with the review is that most of the literature, if not most of the literature actually, were carried out as in vitro tests. So I would need to find more literature that shows more in vivo efficacy, where the chewing sticks are actually tested in real life events. But overall, there should be an advocacy should be planned to increase the use of chewing sticks based on these clinical trials. So for my project extensions, obviously I would like to actually carry out these experiments and, be able to see what these chewing sticks from my regions in Nigeria can actually, what antibacterial properties these chewing sticks from my region in Nigeria have. But also a study by Shetty in 2010 details how most of these plants used as chewing sticks have a high content of tannins, which is essentially a natural compound that acts as an antibacterial compound, as well as other compounds that help healthy gums and teeth. So there's a need for phytochemical analysis in these chewing sticks, as well as understanding if there are certain conditions which these plants can be grown that will increase these compounds, natural compounds within them. Thank you for listening.
Thank you so much, Whoba. This is so interesting. I'm personally very interested by this because I always get a lot of cavities and my dentist is always like, I don't understand why your teeth are so weak. But I had one question and then we'll probably have to hop because of time. But I was wondering, so your presentation, your project was motivated by home practices that you in your culture in Nigeria. And I was wondering, on a more meta level, what do you see in terms of how we can encourage more science studies that take a look at indigenous practices and cultural practices that may not be necessarily widely accepted yet in Western medicine, but that we have so much to learn from, as your chewing sticks example shows?
Well, to be fair, the field is quite niche. There's actually been more extensive research in the chewing stick field. The only reason why it seems like there wasn't that many in my presentation because I narrowed it down to the chewing sticks used in Nigeria. If you actually go online and research some of the commonly used chewing sticks that are more popular, are chewing sticks called neem and miswak that have a lot of systematic reviews and papers written on them. But I feel like, I mean, there's just been recent, discoveries in this field. So I feel like with time, there will be like a growth in, encouraging these traditional practices.
Totally. Awesome. Great. Thank you so much, Whoba. And thank you everyone for coming. This concludes our STEM Talk session 12. And thank you so much. Have a great rest of the conference.